All right, so here's problem 17 from our kinematics practice packet that we did. And it reads, a hobby rocket reaches a height of 72.3 meters and lands 111 meters from the launch point with no air resistance. What is the angle of launch? All right, so if we're looking at this problem, I've drawn a little path for the rocket, nice parabolic path. We're going to have to assume that it starts and lands at the same height. So we've got a maximum height of 72.3 meters and a maximum range that they tell us of 111 meters. And again, they would like to know what is the angle that it gets launched at. All right. So we're going to have to look at this slightly differently. Some people may want to say, oh, look, we have a height of 72.3 and we have a length, if we're talking about halfway, of 55 and a half. And then you may say, all right, let's use the Pythagorean theorem, right? And that'll tell us this, right? And we can find the magnitude of the hypotenuse, and we can find, the angle just by using the inverse tangent of these two sides, and that'll give us the answer, right? And that'll give us the angle. That doesn't work in this case, because if you look at the path that we know that the path of a projectile is going to travel this parabolic shape. All right. So while the sides of this path right to halfway may be linear and straight, the actual path is not. It's curved. All right. And that poses a problem because it's not a right triangle, right? Imagine a triangle with a curved hypotenuse. It's not really a triangle then. So we can't just do the inverse tangent and Pythagorean theorem stuff that we would use for these sides for the distances, because the distance, again, it travels is not straight. It's not linear. It's curved. But we can look at it in terms of velocities, right? Because then the velocities are linear. They are straight, right? They're straight vectors. So if we look at it, the velocities instead, that'll allow us to solve for what the angle that it gets shot at, okay? And we're also going to change our point of view a little bit, okay? So we don't know anything about the speed that it gets launched at, and we don't know anything about any of the speeds in here. But we do know the speed right here at the peak. So at the peak, right, the speed in the y direction we know to be 0, right? So what we're going to do is we're going to work off of everything right here at the peak, at the tippity top of its path, because doing that is going to allow us to solve this problem, okay? So looking at the peak of its path, right up here, we're going to start by first finding the time. We always have to start with finding the time. If we're going to solve any problem in projectile motion, we need to know information about the time. Okay? So we start with y equals y sub o plus v sub o y t plus 1/2 g t squared. So if this is our origin, then y is going to be the negative h, right? Because it's going to be everything below us, right? So in this case, it's negative 72.3 meters, right? So it's going to end up below us when we find out what we're down here. So if this is where we start and this is where we want to go, then the y is going to be negative 72.3 because we're starting up here. So then that's 0. Now v sub o y in this case, again, if we're taking from the top, is equal to 0 as well. Right? And that works out nicely because it wipes out this whole extra t term. And then you're just left with negative 5 t squared, because again, 1/2 negative 10 gives us that. So when we do this out, right, the negative signs cancel out, divide by 5, take the square root, right, we're going to get that the time is 3.8 seconds. Now that 3.8 seconds is the time to go from the top down to the ground. So this is really the time for halfway, right? That's the time for halfway. Well, the time for the whole flight then, because it's symmetrical, is going to be 7.6 seconds, right? So that's whole time. So that helps us. So now we know to go the entire path The entire flight takes 7.6 seconds. That's really important to remember. Okay, so now we can find out the speed in the x direction and we can find the speed in the y direction, which are the two things we need to know if we're going to find this angle. Okay, so to start with, let's find the speed in the x. And the speed in the x is actually really simple, right? We know that v is equal to d over t. And if you look at what we've got, we know the total time is 7.6, and we know how far it's going to travel in that time. And we know that the speed in the x direction is always the same amount, no matter where we are. So if we find it in one place, we know it in every place. So then it's just 111 divided by 7.6. So then we know that v sub x is going to be 14.6 meters per second. So now we need to find v sub y. Right? So v sub y in this case, what we're going to do is we're going to take it from halfway again, because we know halfway stuff and it makes life easier. So v sub y is going to be equal to v sub oy plus gt. Well, if we're taking it from the top halfway, we know that the speed there is going to be 0. Right? If we took it from beginning right here, we have no idea about what this initial speed is. So we can't plug anything in up here. We have to go from halfway where we have information about that y speed. And then it's minus 10, and because we're halfway, it's going to be 3.8 seconds. So we know that when it hits the ground, it's going to be traveling negative 38 meters per second. Okay? So now we've got this information. We know the speed, we know in the y, we know the speed in the x. So now it's just a matter of finding out that angle, right? And again, now we have the x component and the y component for these speeds. So to find v, right, very simply, it's just, again, opposite side and the adjacent side, tangent theta, the inverse tangent is going to be negative 38 divided by 14.6, which is the y over the x. And you're going to get that the angle is going to be 69 degrees when it gets launched. And that is your answer. And if we look at the answer options that they give us for number 17, that would be answer option B. So that's it. That is kinematics practice problem number 17.